Hi folks, Mr. Long here. This would be screencast number 4 of 4 for the Calculus Rules Mastery Test. And so we've done the power rule, we've done the chain rule, we've done the product rule and the quotient rule. The last thing we're going to do is combine the quotient rule and the chain rule. Okay, so here's our first example. Okay, this would be a question where you see a function on the top with an exponent and a function, in this case, a function on the bottom with the same exponent. Okay, so we know that in general, if I have a to the b over, whoops, that's probably not a good choice of letters, a to the x over b to the x, that just equals a over b to the x. Okay, so we use that property to simplify this one. I've got a 4 and a 4, so I just put 4x here over top of 3x minus 1 with one exponent. Okay, so I can see very clearly that this represents a quotient rule question, but I have a function inside a function, so I've got the chain rule. So it's a pretty clear one. This one here would represent u, and then y is brackets to the fourth. Okay, so let's go through this. So here's u. There's the inside function, 4x over 3x minus 1. We've already gone through the quotient rule. So again, take a look through this quotient rule. Make sure that you can follow the example, and as you work through it, you get the same result, hopefully. So we end up with this being du by dx, but again, make sure that you can do it. Go through it step by step. So that's your inside derivative. The next thing you have to do is the outside derivative. And we know that y equals u to the fourth. So that's a fairly straightforward derivative, 4u cubed. And finally, what I want to do is multiply those together. So what I'm multiplying is du by dx multiplied by dy by du. And the first thing we always do is multiply coefficients. There's a negative 4. There's a 4. Multiply both of those. And that gives us that negative 16. Okay. Then I have, on the bottom, I have 3x minus 1 squared. So I put that 3x minus 1 squared below the negative 16. Finally, I've got u cubed. And we remember that u is worth that right there. Okay, 4x over 3x minus 1. And if you notice, I put a separate cube on each of them. There's a reason I did that. Can you see what it is? It's because I have 3x minus 1 squared, and I have the very same repeated factor over here, except it's cubed. Okay, so I've got to look at the fact that I've got an exponent of 2 there, and then the same factor over here with an exponent of 3. When I multiply bases to similar bases, when I multiply powers with the same base, I add the exponents. So that's how I get, to the fifth on the bottom because of the 2 and the 3. And then I have the 4x cubed on the top, and I have the coefficient of negative 16. Okay, so that's how you do a combined quotient rule with the chain rule. Now, one last one here. I'm not going to probably spend a lot of time on this one, but this one is when you don't have the same exponents on the top and the bottom. So here you see you just have 4x squared plus 1 on the top, and then you have the square root of 6x plus 3 on the bottom. So really, it's an exponent of 1 on the top, right, and exponent of 1/2 on the bottom. So same property, top. Oh, so then the question is, if you noticed in the last question, we started by representing it with the chain rule and then did the quotient rule as part of the chain rule. In this example, when the exponents are different, you would do the quotient rule as your primary derivative and then do the chain rule inside those calculations, okay? As compared to the last example where we did, first and foremost, we looked at this as a chain rule question, and then the inside derivative was determined using the quotient rule. Okay, so in this case, it's primarily a quotient, not a chain rule question, but I have to use the chain rule to do that bottom derivative. Okay, so your bottom prime. Again, it's top prime bottom multiplied by top bottom prime. Okay, this one is pretty ugly though. I'm just going to let you look through that. You can see that bottom derivative it's a challenging one because it's square root. And then we know that the derivative of square root is 1 over square root. So when I put everything in to the formula, I end up with something like this, okay, which is not so nice. Now, there is a beautiful way to do some factoring to remove that fraction, but that's a little beyond the scope of this course, I think. So for now, I'm not so worried about that. That's something maybe I may go through as we get closer to the end of the year if we have time. Okay, so this one I don't need to see fully simplified. I'm quite happy if you get it this far right here. I would be very, very, very happy. Okay, so that is far enough in terms of simplification. Okay, and I'll put just a little mark around the outside. That is the function. Oh, something interesting there, the bottom squared. If you notice, the bottom is the square root of 6x plus 3. So if I square a square root, I just lose the radical symbol. Okay, squaring a square root is inverse operations. All right, so that's how we do chain rule combined with quotient rule. Good luck. Remember, rewind, go over things, and then try to do these questions.